Drought affects global agricultural productivity more than any other type of stress. The results are experienced across the value chain, affecting farmers, cattle ranchers, truckers, and more. According to the National Climatic Data Center, the 2012 drought in the United States cost $40 billion in lost crops and livestock. At DuPont Pioneer, we're committed to drought research and developing solutions. We lead the industry in on-farm testing using year-round managed stress environments. The DuPont Pioneer Research Center, located in Woodland, California, is part of the Pioneer Global Network of Managed Stress Environments. The station features approximately 30 scientists managing more than 300 acres, dedicated to drought and nitrogen use research, plant breeding, and seed production. Scientists carefully manage water applications through the application of precision irrigation to select corn hybrids with improved drought tolerance against stringent performance criteria, discovering and developing products to protect yield during drought stress and to deliver superior agronomic performance during optimal weather conditions. Precision irrigation is essential to drought stress research. To help ensure crops receive a controlled amount of water, flexible lay-flat tubing delivers water to each irrigation zone through drip tape buried a few inches under each corn row. This allows the establishment of custom zones to optimize land usage and to adapt water applications to underlying soil variability. The irrigation crew routinely checks water applications and systems. They monitor the end of every tape row to confirm that each strip is supplying the required pressure and water ration. To evaluate hidden below-ground differences, we use TDR technology with access tubes to monitor water uptake. Tubes are spot-checked here for installation quality, using a backhoe to excavate down to the full 3-meter depth. The excavation allows examination of root distribution around the tubes for better interpretation of the measurements. One of the first effects of water deficiency on crop canopy is reduced leaf expansion. We monitor this trait using an array of ground-level cameras positioned upward to capture images of the canopy. Image analysis allows rapid quantification of stress at different points in the season. This measurement also enables calibration of aerial remote sensing to monitor crop development and stress response. These technologies have transformed our ability to collect detailed information and better characterize both our germplasm and our testing locations. Drought interacts strongly with maturity of the crop. Flowering dates are carefully monitored daily with precise observations of silking and pollen shedding for each plant noted. The ears tell the story of stress. In corn plants with better drought tolerance, the ears are filled to the tip with plump kernels despite the drought that was imposed. In less tolerant hybrids, there's a loss of pollinated kernels at the tip. In the most drought-susceptible types, the kernels are scattered on the ear due to incomplete pollination. Commercial checks are grown to provide a consistent contrast to our experimental hybrids. Some plants with specific genetic features for drought tolerance show much less leaf burning and aging. Observing the physical appearance and biochemical characteristics of each plant helps researchers evaluate the effects of managed stress. For key experiments, ears are hand-harvested, and through the use of Pioneer proprietary ear photometry technology, each ear is imaged to characterize yield performance. This diagnostic information reveals how each entry in the experiment responded to the drought treatment and helps us predict performance in future environments. The collected ear photometry information complements our primary data source, the plot combine. Data from managed drought environments was used to bring Pioneer brand Optimum Aquamax to market in 2011 as the industry's first drought-tolerant corn products. The Pioneer brand product pipeline is actively developing the next phase of drought-tolerant products. Managed stress environment centers are an important component of the larger DuPont Pioneer research and development effort, with more than 4,000 researchers working at over 100 locations in crops like corn, soybeans, canola, sunflower, rice, wheat, sorghum, and millet. DuPont Pioneer is committed to applying the latest breakthroughs in science to develop seed solutions that produce more food and improve agricultural sustainability around the world.